Symbols in Ruby are particularly useful as keys in hash maps, and so we are looking at symbols now as our next data type. Symbols in Ruby look much like identifiers, just with a leading colon. So colon Bilbo is an example for a symbol, and so is colon Frodo, colon Sam, colon Pippin, and colon Merry. And in many ways, symbols are and behave like immutable strings, meaning you cannot change the value of a symbol. A given symbol always has the same value. And what is more, if you have multiple occurrences of the same symbol, they always refer to the same symbol object. So if we have two occurrences of colon Bilbo in our code, it always refers to the same symbol object for colon Bilbo. And if you create a symbol, colon Bilbo, colon single quote Bilbo single quote, and colon double quote Bilbo double quote, all refer to the same symbol. And this is very different if you compare this with strings, because the string Bilbo and the single quoted Bilbo typically both refer to different string objects. We can find this out and study this if we look for an object O and call its object ID method, because Ruby returns via this method the unique object identifier for that object O. And so we can find out what concrete object identifier a given object has. So let's try this out at the IRB. We can look at the symbol Bilbo, and symbols always evaluate to themselves. So the value of a symbol is the symbol itself. And I also mentioned that we can write the same symbol like so, and also with double quotes. Now, using the method object ID, we can quickly see that this string, Bilbo, has one object ID, and another string that has the exact same content has a very different object ID. So these two strings with the same content actually have very different object IDs. They're different objects. You don't have to worry too much what this number actually signifies. For now, it suffices that it's the identifier of the object and it's a unique identifier. So this gives us proof that these two objects, the single quoted string and the double quoted string with the same content Bilbo, are different objects. Now, if I have Bilbo as a symbol and I call upon its object ID, and I do this with another occurrence, maybe even with single quotes, and go for its object ID, we can see that these are the same object IDs. Symbols make very good keys in hashes, and that's what they're most popular for, because they provide faster lookup than if we used, say, strings as keys into our hashes. And so we can use symbols such as colon name or colon age or colon height as indices or keys into our hash maps. And we can write this even shorter in Ruby. So instead of using the hash rockets, we can simply flip the colon to the end of the identifier or the end of the symbol, and then this replaces the mapping, let's say here from age to 75 using the hash rocket. We can rewrite this using age:75. So here in this hash we see name: Bilbo Baggins, meaning that we map the symbol name to the string Bilbo Baggins, and similarly for age and height. We can convert a symbol into a string using the toS method. So this converts the symbol Bilbo into the string Bilbo. And we can take a given string and convert it into a symbol using the toSym method. Okay, at the IRB, we have age equals :name for the symbol name, and we first use the hash rocket syntax, Bilbo Baggins, again with a comma, :age, hash rocket 75, :height, hash rocket 2. And this is the definition of a hash map where the keys are symbols. And the shorthand for this is if we actually flip the colon to the opposite end of the symbol, name: Bilbo Baggins, age: 75, height: 2. And again, this gives us a hash map, and you see that Ruby prints it out in the traditional syntax using the hash rockets, but it writes somewhat shorter than when we write or when we create the hash map than if we were using the traditional hash rocket syntax. And in terms of converting a symbol into a string, we can use the toS method, and if we have a string, we can actually call the toSym method and obtain the corresponding symbol. In Ruby, we also use symbols to simulate named method arguments. So let's say we had a method called printFile with a long list of arguments that we don't want to always remember the ordering of. We can use symbols to identify each of the arguments. So this is the name argument here, for instance, a string, and we have the lines argument, the number of lines we want to print, and the number of columns we want to print. And we can precede each of the arguments with a symbol that indicates what the argument actually stands for. And we'll see how this is done a little bit later in this course, but as a teaser, we could rewrite the same call and change the ordering of the arguments, and the call would still go through in the very same way. So here we have the columns first, the name second, and the lines last. So the argument order is irrelevant. And the way this is accomplished is actually that printFile, the method printFile, accepts a hash with keywords as its parameter. So basically this entire list of parameters is handed to printFile as a single hash with the keywords as the keys into the hash, and the arguments, the actual arguments we want to convey, as values associated with the keywords.